and with corresponding pressures and temperatures. If the engine loading is very high, you are subjecting the engine to very high load. Obviously, the pressures and temperatures will be high, and that time it will become more difficult for cylinder lubrication to work. And that time the friction is expected to increase. Friction is expected to be more. So greater the engine load, more are chances that the frictional wear may increase. Why I'm using the word? Because exact conditions prevailing inside will be determined by not just this factor, but many other factors. Maintenance of the piston rings. How the maintenance of the piston rings, they affect the sliding friction between the cylinder liner and piston rings? Any idea about that?
So can you repeat? You were coming broken.
I'm talking about this point. How does it affect frictional wear?
Sir, in due course of time, the piston ring loses its elasticity, sir.
Due to what? Insufficient?
Sir, because
what is that?
Spring tightness of that garter ring, sir, it loses in due course of time. So it doesn't pull the rings to the cylinder liner.
Garter spring kahan chale gaye tum? I am talking about the sliding friction between the cylinder liner and the piston rings. Why that sliding friction between the cylinder liner and the piston rings will increase if the maintenance of the piston rings is not done properly? I'm trying to ask this. You went into the garter spring. Garter spring, is it used for compression rings? Is there a garter spring used for compression rings?
No, sir.
Then it is used for what? Quickly. इतना क्यों टाइम लगता है? तुम लोगों को मालूम है? Yes.
Stuffing
box.
So due to insufficient lubrication due to rise in temperature over the period, the piston ring may deteriorate. So
no, all that is fine. What you're saying, that is another reason. The reason here we are talking about कि अगर piston ring has not been maintained properly, if you have a issue with the maintenance of the piston ring, then is that going to cause increased friction? The answer is yes. Sometimes you will have this condition because piston rings, they are not cleaned properly. Piston rings, they are not sitting properly in their groove. They are at an inclination or something like that. You know, they may be inclined. So when they are inclined like this, so I'm making an exaggerated view. So you may have an inclination. So the piston rings are twisted. So when they are twisted and all, they are not rubbing onto a surface of the liner, but edge of the piston ring is actually kind of scoring the liner. You may have imperfections on the piston ring surface. It may have an uneven surface. So all those things can affect. So piston rings, if the piston rings are not, sitting properly inside, or piston rings might be broken slightly, or the piston rings might have collapsed. So they are going to affect the sliding friction. I'm not saying that in every case of poor maintenance, the sliding friction will increase. In some cases, if the piston rings are maintained poorly, there will be no friction at all because the ring has collapsed. The ring has collapsed. There's a phenomenon called as collapsing of the ring. Ring has actually collapsed inside the groove, and the ring has lost its springiness. The ring has lost its tensility. It is not springing outward and rubbing onto the liner surface. At that time, the frictional resistance between the piston ring and the liner will rather reduce. Are you getting my point? This point?
Yes, sir.
ठीक है, ये खाली बात कर रहे हैं हम कि क्या क्या चीज अफेक्ट करेगी उसके फ्रिक्शन को. Then combustion efficiency. Okay, combustion, if combustion is very good, obviously all that what is generated, so that will apply a lot of force onto the backside of the piston ring, and piston ring will be pressed hard onto the liner surface, giving you slightly greater frictional resistance. contamination of air or fuel. ठीक है, ये actually ये point मैं यहाँ से हटाता हूँ. This is not fitting over here because when I made it, probably I had something else in mind. This I am removing from here. Contamination of air or fuel will rather cause abrasive wear. ठीक है, वो frictional wear को नहीं बढ़ाएगा. So I'm just removing it from here. I think what I'll do is just a minute. Okay. So let's go back, go to the next one. Corrosive wear. Now, corrosive wear is something where there is a confusion कि ये corrosion है कि wear है, किस चीज की बात कर रहे हैं, what are we talking about? So I will say that there are a lot of case studies which have been done where they have found that if you just run the cylinder liner and the piston ring, you can run with very low wear for a long period of time. But when you find that the liner is exposed to the corrosive environment, the same liner wears out much faster. And the phenomena is not just corrosion and wear separately. It is a phenomenon known as corrosive wear, where the wear gets enhanced multiple times. Yes, the wear gets enhanced multiple times in the presence of corrosive environment. Now, what is exactly happening? Let's try to have a look. Are you able to hear me clearly without noise, without my sound breaking?
Yes.
Voice breaking?
Yes, sir.
Okay. So that's what I have mentioned, well-known fact that wear increases in corrosive environment. There are a lot of studies which have been done. So not only liner, but elsewhere also this stands true. Wear is multiple times higher than the individual effects of corrosion and wear. अगर only corrosion का काम कर रहा हो और only wear काम कर रहा हो, इस दोनों को भी अगर मैंने combine कर दिया, the wear will be much more than the combined corrosion plus wear individually acting. And that is why this corrosive wear has to be taken into account. It is serious. What happens actually? What's the phenomena that is explained over here? Not here, but up till here. Sorry. So you will find that whenever the corrosion is taking place, piston ring is rubbing the liner surface. You know, it's moving down, it's moving up, it's rubbing the liner surface. It is removing an oxide film which is formed on the liner surface. Please understand that these alloy steel liners, they have got very good ability of forming a chromium oxide film. Okay, these oxide films, they are hard in nature and they prevent further exposure of the parent metal, the base metal, and thus they prevent corrosion of the liner. But when you have the corrosive environment present, corrosion will first take place. First, the corrosion of the liner takes place. After the corrosion takes place, there is a stable oxide film which is formed on the surface, chromium oxide or some oxide film which is formed. And further corrosion is not supposed to take place. It's supposed to stop at that point of time. But what happens? There is somebody known as piston ring who is continuously rubbing onto the surface of the liner, continuously, and it is trying to actually rub out this freshly formed oil film, oxide layer, which is a very thin nanometric or micrometric, oxide film which is formed on the surface. It tends to remove that because of friction. It removes it. So as soon as that layer is removed, again the liner gets exposed to the corrosive environment, and again stable oxide layer will be formed. By that time, the piston ring again comes up and removes this. So this is a chain effect, a cascading effect which is there. Can you hear me?
Yes, sir.
Yes, sir.
So you have the corrosion which is combined with wear, causes oxide films to be instantly worn away. corrosion causes the oxide film, but then there is frictional wear taking place. It causes this oxide film to go away immediately. Again, it is caused due to oxidation products of sulfur. We know that corrosion is taking place because of this sulfur content of the fuel. And there has to be some other conducive conditions which will cause the acid formation. Lower part of the liners, owing to low jacket cooling water temperature, may cause moisture condensation and sulfuric acid attaining its dew point, accelerating the corrosive wear. Please remember that corrosive wear is not just taking place in the upper part of the liner, it is more prone to take place in the lower parts of the liner, because at the lower end you have low jacket cooling water temperature, you have the low liner wall temperatures, low exhaust temperatures and all. So there are chances that under these low temperature conditions, the sulfuric acid, there will be some moisture condensation, and those sulfur trioxides, they will combine with the sulfuric acids, and this sulfuric acid will reach its dew point and settle down on the liner walls. And this will cause an acceleration of the corrosion taking place. Is this clear?
Yes, sir.
Yes, sir.
तो ये क्या है? Cascading effect है. First time corrosion causes stable oxide film. Very next, piston ring goes downwards, removes the oxide film. Corrosion again, very stable oxide film form. Again, piston ring goes upward, removes this. So this is a continuous phenomena which is taking place, and it increases the corrosive wear. It increases the wear multiple times actually. So this is a serious phenomena, and that is why you need to have sufficient alkalinity and the high temperature of the jacket cooling water maintained to mitigate this. So maintaining alkaline cylinder lube oil film on liner surface, that is one, and maintaining a higher jacket cooling water temperature, number two, it will mitigate this corrosive wear. It will reduce the effect of this corrosive wear. Is this clear to everybody?
Yes, sir.
Let's have a look at some. Yeah, let's have a look at this. This is a pictorial representation, and you can see that if you are only having wear because of friction, you get, say, wear rate of 1. Only because of corrosion, you get a wear rate of 1. Separately, they are acting, or they are acting combined also, you'll get 2. I mean, combined means individually acting. But when they act in unison, together, they attack, the wear rate increases 10 times. That is the effect of corrosive wear. Okay, and this is a schematic representation. It says that oxide layer removal is taking place, exposing the surface to corrosion, followed by contact between the piston ring and the liner surface structure triggers the corrosive wear. So ये क्या कर रहा है? Oxide film form हो गई. Piston ring is moving, it tears off, it removes this oxide layer, and fresh layer is exposed. Again, it will be subjected to wear, corrosive wear. Then piston goes downwards, it removes this again oxide film once more, and this process continues. So what are the preventive measures? I already told you. Roll number 31. Roll number 31. Roll number 31. Can you unmute yourself? 31. Roll number 31. Are you sleeping?
Sir, sorry to interrupt, but he's from Mumbai and he's facing network issues since the cyclone. Some problem with the fiber network of Jio there.
So how is he able to hear me then? Then what is he doing in my class? You can say that, fine, everybody faces issues, so he is there for attendance only. Because I'm sorry to say, I'll have to remove him from the meeting. This is proxy then. If he cannot speak to me, it's proxy, virtual class, and he's supposed to be attending the class. He may have a problem. If he can't hear me, then what good he is doing in sitting in my class? He is being removed from the meeting. He may have any type of problem. If he cannot respond in my class, he is absent from my class. Roll number 36.
Yes, sir.
Yes. Tell me, what are the preventive measures to prevent corrosive wear?
Sir,
Roll number
lubrication.
36. Did you hear me? Yes.
Sir, lubrication.
Lubricant. Any type of lubricant will help in preventive corrosive wear?
No, sir. Alkalinity of lube oil and high water jacket cooling system.
Okay, very good. Okay, you can mute yourself. Thank you. Okay, so then we move on to abrasive wear. Abrasive का मतलब क्या होता है? Can somebody explain to me in very simple English what is an abrasive?
Sir, fine particles of aluminum and
अरे यार वो एल्युमिनियम कहाँ एल्युमिनियम में आ जाता है माय डियर. एल्युमिनियम ही एक एब्रेसिव है क्या? Yes, good that you are correlating it. That's a good part. But abrasive क्या है भाई? English में पूछ रहा हूँ. I'm not going into the technical this thing. English में abrasive का मतलब क्या होता है? What is the meaning of abrasive? Yes, anybody can. Yes, roll number 20 wants to say. 20.
So very small particles that can cause wear and
by
tear.
which we can clean or shine something.
Correct. We can clean or shine something. Abrasive is a hard particle. Very simple example is sand. अगर मैं sand लूं and you take your goggles and you scratch it, will you find that the goggles will remain fine?
No, sir.
no, sir.
No,
it
sir.
will
No,
remain-
sir.
Just rub some sand or some mud. You know, just take some mud and just put it on the glass and you just rub it dry. What will happen?
It will have some scratches.
So all of you have worked with some abrasives in the workshop. Tell me what abrasives you have used in the workshop. Example.
Emery paper.
Mary paper, sir.
Yes, memory.
Even
Yes,
on
grinding.
grinder, sir.
Yeah, grinder. Very good. What else?
Sir, files.
Files.
File. Very good. So you have all worked with abrasives and you've seen the abrasives are used in the daily life. You're using it in the kitchen. You're using it for cleaning. Those are all abrasives. Those Scotch Brites, steel balls, all those, they are abrasive material. That's how they scrub it. Anything which is used for scrubbing is an abrasive. So abrasive, you know, is harmful for any system if the system is not hard enough. If the abrasives are harder than the system, it will scratch the system. If the abrasive is softer than the system, it will not be able to scratch the system. Got it?
Yes, sir.
So
Yes,
abhi we are talking about abrasive wear where the abrasive is harder than the system. If the abrasive particles are softer, they will not be able to harm the system. But if the abrasive particles are harder, definitely they are going to harm the system. So obviously we have something in the oil. You have studied about the same known as cat fines. So what are cat fines? Can roll number 8 tell me what is cat fine? Roll number 8. Roll number 8, can you tell me what is cat fine?
Yes, sir.
Yes, what is cat fine? Roll number 8. Roll number 8, are you listening to me? Are you listening?
Yes, sir.
I can't hear you. Hello.
Yes, sir.
If you are listening, then please respond. What was my question? What was my question?
So what is cat fine? Cat fine.
Bolo, quickly. Bolo.
So this is hard.
You are searching on the net. ये नेट पे सर्च करने वाली चीज है, गूगल को ही साथ में लेकर के रखना है लाइफ में। आपका दिमाग है कि नहीं है, आपका हार्ड डिस्क में कुछ स्टोर्ड है कि नहीं है, सब कुछ गूगल से ही लेना है। तो आपने यहाँ पे पैसा क्यों खर्चा किया है 4 साल का इंजीनियरिंग करने के लिए? अगर गूगल को ही आंसर देना है तो इंजीनियरिंग डिग्रीज आर वेस्ट।
No, sir.
When you don't know, अगर इतना टाइम लग रहा है तो you don't know. Simple. Answer is very clear. Roll number 29.
Yes, sir.
Answer.
Sir, cat fines are aluminium and silicon particles. That means that is used for catalytic cracking while refining the oil.
Very good.
These particles get into the system and are very small and can't be removed by filters also.
Very good. So catalytic cracking is one process. Those who are not aware of that process, please go through that process. Very good. So excellent. Please go through the catalytic cracking process. Those who are not aware of that, because it's not there in your syllabus. Probably it is never covered over there. Even if it is touched upon, it's only in the words it has been covered. So cat fines consist of alumina, okay, and silica. Actually, in that form, aluminum and silicon fines. Cat stands for catalytic fines because they're extremely fine particles. That's why. And alumina and silica fine particles. That's why cat fines, alumina and silica fines. So alumina and silica particles, they are very hard in nature. You know, sand, silica is sand. It is consisting of silicon, which is very hard. Alumina is also very hard. Please remember this. So alumina and silica, they are very hard in nature, and they are harder than the liner, piston ring surfaces and all. If they come into the fuel, when you inject the fuel, they will cause what? They will cause the ash formation. They will not burn away because these are not inorganic in nature. It will form ash, and this ash will remain deposited onto the ring lands, onto the ring grooves, and it can come in contact with the liner, and it can cause the scratching of the liner. This is causing the ash deposits on the piston lands. And when the piston is moving up, moving down, moving up and down, every time is scoring the liner. It's actually continues to scrub the liner every time. And that's how this abrasive wear continues to take place. This is not the only thing. You may have abrasives coming from scavenger. Some of you will be sailing to Middle East countries and all. And somewhere in the time of summer, you will find there are heavy sandstorms which they undergo. I mean, there are sandstorms which are coming. And your turbocharger, though it has got a pre-filter, in spite of that, you will have some sand being sucked by the turbocharger, sent to the scavenger manifold and through the scavenger into the cylinder liner. Again, these can act as abrasives, but every time you will not find abrasives coming through the scavenger. But sometimes you are there in port, your auxiliary engine is running. Are you listening? Roll number 10, can you hear me?
Yes, sir. Yes, sir. I can hear you.
Okay, so sometimes you are there in a port and you are loading or discharging an abrasive cargo or dusty cargo, and that time your auxiliary engines are running, your generators are running, and that time also these particles can come through the scavenger and can cause more abrasive wear of the liner at that point of time. Okay, then another thing is products of mechanical wear. So when you have some wear taking place, frictional wear taking place, some metal wear particles will come out. Obvious thing is there, you will have some metal wear particles. Now these metal wear particles, if they get embedded between the piston ring and the liner, they come in between the oil over here. Then obviously as the piston rings are moving up and down, these particles will cause scratching of not only the liner surface but also the piston ring surface and make it uneven. So metal wear particles also, which are there in the oil, which are there because of the frictional wear and all, they will also cause increase in the abrasive wear. Corrosion and the oxidation products, whatever oxide layers are formed, whatever corrosion products are formed, some of them will be harder and they will remain sticking to the liner wall. So as the piston ring moves up and down, some of these corrosion products will be trapped in between the liner and the piston ring. And if they are harder, they will definitely score the liner. They will definitely cause scratching of the liner. Okay. Then hard unburnt combustion products. So अगर आपका carbon है, soot है, so that will be normally not very hard, but some of the carbon may tend to become very hard, and that may get deposited on the ring lands. So you have the ring lands on the piston, so that is there. So you have so these are the ring lands. So you may have the hard carbon deposits. Also, you can have calcium carbonate deposits. Remember when I was teaching you the additives, I told you that if the oil is highly alkaline, if the TBN value is very high, then the calcium carbonate deposit ash or calcium carbonate ash will get deposited on these ring lands and also into the grooves. And it is very hard in nature, so it will cause bore polishing. It will cause abrasive wear of the liner because it is very hard, calcium carbonate. So as it is, piston is moving up and down, it is going to score the liner. Any point which do you have a doubt which has been discussed over here? Please let me know. Any point you have a doubt, please let me know. Roll number 33, are you there?
Yes, sir.
So you have understood?
Yes, sir.
Okay. What about roll number 17?
Yes, sir.
Okay. $25? You have understood?
Yes, sir. Yes, sir.
I hope so that you are telling me correct, because many times it happens, and then when I ask you, then you're not able to explain. I hope that you're making some notes, because you
Yes,
won't
sir.
be finding explanation. Yeah. Then
Excuse me,
comes
sir.
the yes.
Sir,
Go ahead.
abrasive wear also depends on the speed of piston, as you told about corrosion wear.
Speed of the piston पे तो सभी wear actually depend करता है, but speed whether it is low or it is high, abrasive wear will mainly depend on the presence of abrasives. Let me go to the previous slide. अभी इसमें जो भी बात करी गई है, whatever factors I have put up over here, ये cat fine is an abrasive. Okay, abrasives coming, sand or dust coming from scavenger is an abrasive. Ash deposit, whether it is because of the cat fine ash or it is from the alkaline ash or it is from some other unburnt products of combustion, all these are abrasive. Mechanical wear, metal wear particles are abrasive. Corrosion oxidation products may or may not be abrasive in nature. Not always necessary, but usually oxidation products, they are very hard, like chromium oxide layer which is formed is very hard. So it will definitely act as an abrasive if it comes trapped between the ring and the liner. And then any hard unburned carbon products, and obviously this I have talked about. So these are all abrasives. So agar aapka, even if your speed is less or your speed is more, it does not matter. If there is abrasive in between, abrasion will take place. Okay, you can't avoid that. Only thing what can avoid abrasion is the thickness of the lube oil. If the lube oil film thickness of the lube oil film, if it is, let us say 10 microns and the size of the abrasive particle is only 2 microns, then there are chances that their abrasive particle will never be getting trapped between the two metal surfaces. It will just float in the lube oil film and it will not cause damage to either of the surfaces. But if the abrasive size becomes 10 microns and the lube oil film is also 10 microns, a lube oil film is just 11 microns, then there are chances that you will have some abrasive wear taking place. And if you have abrasive particle size bigger, 12 microns, and lube oil film thickness only 10 microns, 100% the abrasive wear is going to take place. Is this logic clear to you? The logic which I told you?
Yes, sir. It is clear.
That is why That is why there is always a logic of putting a particular size of filter in the lube oil line. Here, so we are talking about cylinder lube oil. So it is not that recirculating system. It's an open system. One side the oil goes, the other side the oil is consumed. It never comes back. But all other lube oil systems, you have a filter for this purpose only. The filter should be able to filter out the size of the particles so that the scoring or that abrasive damage of the bearings and all can be prevented. Next comes the scuffing damage, also known as the adhesive wear. Adhesive से क्या मतलब है कि adhesion is taking place. Something is sticking to the other. That means there is some sticking taking place between the piston ring and the liner. So how can the piston rings and liner stick together? They stick together by a procedure known or by a method or is known as micro seizure or micro scuffing or micro welding. These are the various terms which you will come across. Micro seizure occurs because of micro welding. Why is the micro welding taking place? Because when there is a liner surface and there is a piston ring surface, if I try to magnify that, I make it too large. I will say that this is the liner surface. I'll say that this is the liner surface and I have a piston ring over here, too large. I make it say 5 times larger, the piston ring. Now, if you try to see under electron microscope and all, you'll find that liner surface is never smooth. It's having some kind of rough patches and all, wavy pattern and all. This is also having some wavy pattern and all that is there. So what happens when the lube oil film, you have a lube oil film in between that is taking care of that. It's not allowing the metal to metal contact. But there will come a time when the load is very high near a TDC and all, there will be some metal to metal contact. Lube oil film thickness will decrease because the piston velocity is decreasing, and you will find that this comes closer. You will find that the piston ring comes closer because the oil film thickness has decreased, and that time at some point of time this metal to metal contact between the surface asperities or surface imperfections will take place. And when this is taking place, there is a very high local temperature generated over here. Rubbing, very high local temperature generated over here, and it causes a very small local micro welding. Now you have a local micro welding which is taking place. Now, is this micro welding going to cause seizure? Is it going to, is it sufficient to stop the momentum of the piston ring and hold the piston in place and seize and stall the entire engine?
No, sir.
No, sir.
It's a micro seizure. It's a micrometric size, nanometric size. It's a very small seizure, and it's going to subsequently break away. So it's going to just very next moment it breaks away. And when it breaks away, it tears off the metal non-uniformly. Sometimes the portion of the liner tears off and remains sticking to the ring, and sometimes the portion of the ring tears off and remains sticking to the liner surface, further increasing the surface asperity, further increasing the surface imperfection. Further, next cycle, further causing more micro welding and more micro seizure. This is called as micro seizure, and it leads to micro tear, and further causing an aggravated micro seizure and micro welding taking place. It is known as scuffing. Metal to metal contact due to surface asperities on the liner and piston ring takes place. Boundary lubrication is responsible. Higher load conditions, they are responsible, and they may cause excessive local friction because surface asperities may come into contact. And that is the time you need to really, see that how much of this is taking place, because you can't avoid those surface imperfections. However smooth it may be, some of it will always be there. So it causes local micro welding, and then metal micro tear occurs. That tearing occurs if it is not healed. Healing कैसे हो सकता है? अगर हम lube oil बढ़ा दें, if we increase the lube oil quantity, probably the lube oil thickness will increase. Probably then subsequently the piston ring will be rubbing not directly onto the liner surface, but it will be separated by a thick lube oil film, and that is the time there are chances that healing may occur. But otherwise, what will happen if it is not healed in time? Extent of micro welding continues to increase, leading to macro seizure or scuffing. Micro se macro ho jayega, bada ho jayega. It increases. So you have a macro seizure occurring. Large areas will be exposed, and that is called as scuffing. Macro seizure, scuffing, or adhesive wear. Torn of material further aggravates abrasive wear. This you should always remember, because that is either remaining in the oil, it is in the oil film, or it is remaining sticking to the piston ring surface, or it is remaining sticking onto the liner surface. These are some of the causes of adhesive wear. These causes will aggravate the adhesive wear. Local removal of oil film, poor lubal retention, because if you have liner surface which is highly polished, it's a mirror-like finish, very smooth, then oil film will not be retained over there. And if oil film cannot be retained over there, there is a likelihood that piston rings will rub the liner surface. Then you also have lube oil film thickness removal. Okay, and this lube oil film thickness removal can be because of high temperatures, because of poor lubrication or boundary conditions, incorrect quantity, incorrect quality, incorrect distribution of lube oil, incorrect timing of lube oil, cylinder lube oil injection supply to the cylinder, blow past. If the blow past is taking place when the sealing is not taking place properly, or if the piston rings have collapsed, blow past will take place. So blow past removes the oil film locally in that area. Again, it can cause further micro seizure. It can cause scuffing damage because oil is not present in a certain area because of the blow past. Definitely, you know, I told you if there is a high lube oil, being high amount of lube oil sent with high alkalinity content in the lube, cylinder lube oil, then each of all of this lube oil may not get consumed, and it will form a lot of ash deposits on the piston ring lands, which can cause bore polishing of the liner. Bore polishing means liner bore internals, they are getting polished, and liner, that honing marks which are there on the liner surface, they are getting converted, you know, into smooth mirror-like surface. And mirror-like surface will not be good for retention of oil, and where the increased wear will take place. Water condensation. Water condensation causes the cylinder lube oil film removal. Remember that it will when you have a lot of water condensation, the oil film in that area gets removed, and you will have problems occurring in the lubrication in that particular area, may lead to micro scuffing or scuffing. Of course, boundary condition has been covered already, so I'll not, I think it is a repetition. Effect क्या है adhesive wear का? Effect of adhesive wear is that the normal liner wear rate is considered to be 0.1 mm per 1000 hours of diameter. So diametrically, the liners are supposed to be reducing 0.1 mm every 1000 hours normal wear. But if the macro scuffing or macro wear is taking place, adhesive wear, it can reach to several millimeters per 1000 hours. It can reach to 2, 3, 4, 5 millimeters per 1000 hours several times. Yes. And micro tear particles, as we know, they are further acting as an abrasive, and they increase the abrasive wear. So first you have an adhesive wear. Adhesive wear leads to further abrasive wear. So that is how the abrasive wear, adhesive wear has got a cascading effect, and it increases the abrasive wear. So first adhesive wear will start, then abrasive wear will aggravate, and that will increase. So what are the mitigating measures? Increase the cylinder lube oil feed rate, and if the cylinder lube oil feed rate is too high, then decrease it. So the too high will cause lot of ash deposits. Lot of ash deposits is going to cause lot of abrasive wear, and that abrasive wear will cause bore polishing of the liner. It's indirectly related, and that bore polished liner will cause adhesive wear. So things are interrelated. How they are interrelated, that you have to sit quietly and you have to think about it, how it is going to affect. Bore polishing must be minimized. वही उसका ही effect है ये. If it is excessive, then bore polishing will take place. If it is less, then again it can cause directly the adhesive wear to increase. Honing of the liner. Do you know what is honing?
Yes, sir.
What is that?
Sir, it is done to polish the bore of the liner by honing tool.
Polishing नहीं है, ये उल्टा है.
To make some structure which can retain the lube oil on it.
Yeah, so it is actually kind of micro roughening of the liner surface, not macro. ऐसा नहीं कि आप उसको छुएंगे तो you'll find कि it has become rough or something. It's a micro kind of roughening of that surface with a carbonundum tool, carbonundum tip tool, where it hones the liner surface so that the oil can be retained onto the liner walls. Because liner, once it becomes super glazed, mirror-like finish, you can actually see your face on standing inside the liner. You can see your face. You can use the liner like a mirror. And how can you expect a mirror to retain the oil? Obviously, whatever you put on the mirror, it just falls down. It just slips down. So that is why bore polishing has to be minimized, and honing of the liner which has been bore polished, which has become mirror glazed, has to be done. And we can use piston rings which are ceramic plus metal coated. CERMET. CER stands for ceramic and MET stands for metal. CERMET coated piston rings can be used. So nickel, chromium and chromium carbide and molybdenum based rings can be used, and they tend to reduce the adhesive wear because they tend to be very hard, so they will not get micro welding. They will not get micro welded to the liner surface in spite of that surface imperfection and all. So that is the advantage, and that's why sometimes they can be used. I will talk about the clover leafing in the next class. Please remind me. There is next thing which is clover leafing. So we'll talk about this adhesive wear also. I'll show it to you in the next class.